Just a quick intro. This is Praveen Vengalam. I'm one of the co-founders and VP of Engineering at Anuta. And I'll be walking through quite a few of the Atom capabilities. And it's going to be quite a few clicks as well. So hopefully we're going to enjoy. And feel free to interrupt me if you have any questions. And broadly looking at the demo flow, we're going to look at where the Atom is deployed and how the demo is accessing the target infrastructure. And we're also going to look at all the basic foundational pillars we saw, like automation and telemetry, closed-loop automation, and reporting. All of these things we're going to take a look at in the demo. So just to refresh the team, so this is the vertical pillars that we're going to go through in the demo, and we're going to go from left to right. And we'll also take a look at how we are extensible. If time permits, we'll take a crack at it. Otherwise, one point to note is pretty much everything that we're going to demo today, it's model-driven, it's pluggable. There is quite a bit of capabilities that come out of the box, but at the same time, customers can write their extensions in pretty much every imaginable place, like device modeling, the apps, and everything else. Okay. So we'll switch to my browser. Okay. So we're going to walk through the deployment aspects. So one of the biggest differentiator for Atom is we are catering to a customer that has huge infrastructure, various domains, and that may require extensions because their use cases tend to be unique. And that's how the demo flow will go, and feel free to interrupt me if you have any questions. So the Atom software that we're looking at now is deployed in the Google Cloud Platform, and it's accessing the infrastructure that's deployed in our data center. And we're going to walk through the deployment itself. So we do require one or more clusters, depending on the resiliency requirements. And on the Google Cloud Platform, all the demo environment has been deployed as a single cluster. And we also provide dashboards to kind of manage, monitor, and get a snapshot of our infrastructure. And since we are looking at a huge infrastructure, the software footprint itself tends to be quite big. And in some scenarios, we may be starting small when I have 1,000 devices. But as the infrastructure under management tends to grow, we will need to scale horizontally. So we will need quite a bit of checks and balances, KPIs, reporting. So we provide quite a bit of that reporting so that we are manageable also. Okay? So this is the Grafana dashboards that integrates into Kubernetes to report some of the metrics. And we also have the microservices reporting quite a bit of the KPI information so that the underlying KPIs, the beyond the CPU and the memory, we also report how long it takes to inventory a device, how long it takes to complete a closed-loop automation action. All of the information is also reported. So at any given time, if at all the throughput or performance is not as expected, we can scale out like through some of the threshold definitions, or we can scale out manually. So if you see, this is all the different dashboards we expose to our customers.
Do you have dashboards available pre-built in Grafana? If you're new to Grafana or have never used it, Grafana can be kind of daunting to build, to get a basic dashboard up and running. Yeah, so you guys have templates and stuff that help customers get off the ground quickly?
Correct. All the templates that we're seeing here are packaged along with the product. Okay. And the dashboards that we see here are dashboards that report Atom's own metrics, and also, if required, the device telemetry also. For example, if you see this is the device telemetry information, the fact that we have data in the system, we actually have mechanisms to even produce the Grafana dashboard itself through a model-driven mechanism. That is something that we'll take a look at down the line. So this is the Grafana dashboard. And also, the Grafana dashboard will not be able to provide all the troubleshooting and the manageability aspects of the Atom platform itself. So we also have a system management function within the Atom platform that provides you significantly more deeper visibility into what microservices are deployed and what are the infrastructure components where we are using. We may be using Kafka, we may be using InfluxDB, and all the relationships between the microservices, dependencies. So if you click on any microservices, we're going to know what services it provides, and we are also going to know what are the dependencies it will have downstream. So at any given point of time, we're going to know what our dependencies are so that we know what to report to the end user. So that is the manageability aspects, and we have significant more troubleshooting aspects. Again, all of this keeping in mind the fact that we are working with large-scale deployment. We're expected to provide a resilient software, and we're expected to provide software that might be deployed across multiple data centers for DR reasons, and we have to scale horizontally and we have to be like a resilient software. So again, to address the deployment complexity, we have built quite a bit of the manageability of our own platform, and that is a starting point. And once the software itself is deployed, and we start working with the devices, the first and foremost thing that gets done is onboarding the infrastructure into the Atom platform. That's going to go through discovery of devices. It's going to go through discovery of inventory through SNMP trap, or other mechanisms. And it's also going to go through a discovery of configuration through API or through the more classic mechanisms of CLI. And since we have a model-driven approach, all of the information, if it is structured or unstructured, the information is going to be translated into a model-backed configuration, so we can write queries easily against the model. And all of this is done at scale. And in the interest of time, we will not be going through some of the resource management aspects. If time permits, we'll dig into it. But one aspect that we're going to take a look at is the topology. So we are working with customers that have global deployments, like 25 different locations, maybe more than that. In those scenarios, we have infrastructure deployed everywhere, and customers want to see that infrastructure in a single pane of glass. So when we have hundreds of thousands of devices, it's not practical to see that much information in one screen. And that's where some of the innovations that we have done includes the topology, where we can look at how to restrict the views, for example. We can organize the resources into logical groups like regions. And the regions themselves could be based on geography, and it could be based on functionality. The functionality could be more like logical grouping based on architecture, access switches, distribution switches, something like that. Or in this case, we're looking at a global region, like a IWAN domain, DMVPN domain that's spread across multiple locations, and we're looking at one particular hub location. And it's not just showing the topology itself, but we can overlay information on the topology. For example, we can take a look at alarms, and we can overlay the topology with alarms. And we are going to bring in more capabilities here so that we can annotate the links with latency information, utilization information, and we can filter down like this topology to show heat map as to where my utilization is high, utilization is low, underutilized links versus overutilized links. We're going to keep doing that. And all of this is going to be done at scale, and also in a way where customers can bring in their own use cases into this topology.
How do you set those metrics for the thresholds and the hotspots and stuff like that? Is there a learning mode, or you're manually setting all those thresholds?
So we have some defaults built into the product. Like, for example, if it is a BGP neighbor flapping is one example. So we take a look at the recommendations coming from the vendors, and we have some defaults, but customers can come in and they can change the defaults to their requirement. Also, as you can see from here, this is how we can restrict the scale. We can compress the nodes based on device type, family, and we can also compress some of the nodes that are not important to visualize. Probably the devices that are healthy, they don't need to be brought into the topology view. So this is how we can restrict the scale that we have to address, so that we can provide a better visualization. So this is on the resource management. So one thing before we go further is we can discover infrastructure at scale. That is the physical infrastructure discovery or virtual infrastructure discovery. The inventory it has, the configuration it has, and all of the brownfield information can be absorbed, and we have resources to work with. And just a quick glance. So this is the devices that we can work with, the logical grouping device groups, and some IP address management that we will have to do, like integrate with info blocks or BlueCat, and the topology that we just looked at, and organize the resources into logical resource pools so that we can go and provide like guidance to the customer when deploying services. I can say which resource pool to deploy it on. All of this is done as an upfront work, and then once we do this, next is going to be service provisioning. So this is where from customer to customer requirements are going to change quite a bit, and we will provide customers starter kits, like data center starter kits, like branch automation starter kits, campus starter kits. But ultimately, customers will have to do some fine-tuning in cases where their use cases are fairly more advanced. And for that reason, we provide extensibility within the platform that allows us to extend what we have provided as starter kit, or actually go and develop something completely from the scratch. So if you can see from here, the variety of use cases can go from data center. This is a data center use case here. and L2 VPN, and an L3 VPN, and a different flavor of L3 VPN, and a branch use case like a managed CPU use case, or it could be like a day zero kind of service where we're deploying QoS across a bunch of switches, or a VLAN provisioning across one or more switches. So for the demo, we'll take a look at one use case in the data center. So in this scenario, what our customers are doing is they want to provision an application in the data center, and the network segment is shared. So they have L2, like VLANs, they have firewall and load balancer, info blocks, all of these things are already deployed, and we want to onboard more and more applications. So that is the use case here. So if you see here, the application delivery service itself is a service package that has been uploaded into the system, and the UI itself is model driven. We also have API to back this up, and as you can see, all of this structure that we're going to see down below is described in a Yang based service model, and the UI is going to paint automatically once we deploy the model. So here we have standardized the load balancer configuration into different kind of profiles, and we're going to specify what is my load balancing option, persistence option, health monitoring option, and this is going to be used down the line. So let's go to the application services here, where we have deployed 2 virtual network segments, and there is a gold segment, there is a silver segment. We'll go into the gold segment, and then we'll deploy the application on top of this shared segment. And you're going to see a picture here, and this is the segment that we have already deployed, and on top of this segment, we're going to deploy an application. And what does an application mean? So application may mean different to different customers. One enterprise may say, I'm going to only allow deployment of a VIP on the load balancer for my customers. Security aspects are already redefined. We may have a scenario where we allow the application owner to deploy a lot more than that. And so since that requirement is going to vary from customer to customer, we allow extensibility, and the flavor that we're going to look at is a specific scenario. So in this scenario, the application deployment is going to involve deploying a VIP. I'm going to load a template here. So in this scenario, the application deployment is going to involve deploying a VIP address on the load balancer, and it's going to also involve attaching a certificate on the load balancer, and it's also going to involve attaching servers behind it, and the load balancer profile we created in the earlier screen is also going to be deployed onto the load balancer. And we're also going to go and configure the firewall to allow the traffic for this VIP address from the trust zone to untrust zone, and we will also register the FQDN and the A record and host record. So this is what one of our enterprise customers' application deployment looks like. And the UI can be used as is because it's fully functional, or this UI is backed by an API, and the API can be used to integrate into a ticketing system or a self-service portal of customer's choice. Both options are available. And we have customers using both. Large enterprise customers typically tend to use the API approach, and customers that may not have a self-service portal, they tend to use the UI as a go-to-market option. So both options are available.
Are there any limitations to the API, or is everything you see here available via API?
Everything we see here is available. Pretty much all the UI is given to the model, and if you go and augment the model, go and write conditions, we can go and paint the UI differently.
When the vendor releases new feature, how quickly are you able to keep up with them?
Okay, so the service model itself is vendor neutral, because the service model is working on top of a vendor neutral device configuration store. And if the vendor is going to come up with a brand new capability like that we have not seen before, let's say a brand new device comes up, so then it may take anywhere from 2 weeks to 3 weeks. But if it is augmenting an existing device that we already support, to add a feature incrementally, it may take a couple of days. But it really depends on what is that target use case we're working with.
So let's say they support new type of load balancing algorithm, which is not a major change, but would you immediately support it, or you will have to add that support to the ATOM?
So if it is just a small change as new algorithm, it's probably going to be hours, or maybe matter of maybe a day or less than a day. And customers can themselves add that also. They don't have to wait for our patch. It's pretty easy to go and add that in the UI itself. We have a device package support where we can go and do the augmentation.
So what you're saying basically is that the compiler for the network configuration is something that can be extended by the customer themselves.
Correct.
Right? And
yeah.
I think this is very powerful. I have something in my mind that I wanted to ask you. So I work for a big telco, and for us, this is very interesting, especially if you're thinking, we have a very pervasive presence all over the world, and we might want to sell this to internal customers as a managed service, right? So we have, say, a centralized data center where we deliver Atom as a service to internal customers. Now, two questions. One, is there any latency-sensitive components in your microservice architecture that needs to stay close to the data sources for a filtering purposes, or again, because it's latency-sensitive? And B, in terms of security concerns, people might want to have some proxies, some data collection, telemetry collection agents close to the data sources that then do some scraping of the data and sanitization, and then ship the data over to this centralized data store and telemetry analytics processor, say.
Yeah.
How does it work?
So we have a collector that can be deployed close to the equipment if required. And that collector doesn't need a Kubernetes. If you choose to deploy the collector, it can deploy as a virtual machine or as an app closer to the infrastructure. So typically, when we don't have bandwidth requirements, typically they're deployed much more region-wise. I want to deploy one collector possibly for the whole eastern region. That might be one scenario.
So this is where the bulk of the data traffic happens, right? From the real source to the data collector.
Correct, yeah.
Okay.
And then, but again, it depends on the deployment model. All the collectors themselves can be deployed as microservices in the centralized location, but not all customers' requirements are the same. In some cases, as you said, they have to be deployed close to on-prem and then close to the infrastructure, and we may not have Kubernetes at that location. So in that scenario, we have to deploy that as a virtual machine, and we will be able to do some collection, packaging of the data, and then shipping it back to the central location.
So you can support this like a hybrid deployment mode where the bulk of the microservices are deployed in a Kubernetes centralized cluster,
Correct.
and then you have some other components that are distributed in other form factors, like VM-based.
Yeah, and the first question that you're asking, we do have scenarios where latency is important for the end user, because there is a specific SLA for the end user with respect to user experience. There is a specific SLA for an API also. There is a client not bound that is accessing our API. So for that reason, we can be distributed across different data centers, because the data communications deployment itself is across different continents. So in those scenarios, the components that provide the API access themselves can be distributed globally, so that you're accessing a local component. But we have to be fronted by a DNS server or a similar mechanism upfront to route the request to the appropriate provider from our side. We have an API gateway that will be plugged into the customer's load balancing option.
More than the user interface, I was meaning like maybe there's some parts of the architecture that require to have low latency for the architecture to work, for the control plane to work.
Right.
I'm not so much concerned about the speed of the API because the user experience might be impacted. I'm more worried about, does it work properly if I distribute some components like 2,000 miles away from where the
Right. Definitely, I think that device communication is one area. We start provisioning a device. Maybe it takes a long time. The device might time out. Maybe there's some other dependencies there. We will have some latency dependencies. Of course, we're working with large infrastructure that's probably over WAN. But there is a lot of customization in the tool that you can fine-tune what your expectations of the device responses, or even within the system, closed-loop automation. If at all we need it to be real-time, we have to scale out more aggressively. If it is near real-time, maybe different. Maybe it's not near real-time, it's different. So we will have enough tuning required in the software to be able to cater to that. Okay? So this is the application delivery use case here. Once we deploy the application, we can step into this, and we can also maintain the life cycle. It's not just one-time deployment. It's also to go and change the existing services. We can do that. And also, apart from taking care of the provisioning, we can also make sure that there is no configuration drift. And this is also a huge use case for our customers, where we routinely monitor the infrastructure. We understand what configuration is being changed on the infrastructure, and we will provide a mechanism to reconcile the configuration. For example, here if you see, we will have a scenario where some configuration is lost accidentally, and we will be able to see what configuration is lost and how we're going to recover the configuration. And in some scenarios, maybe the configuration change on the device is as expected, and we will be able to provide the appropriate guidance. So this is on the first pillar that we take a look. So we can discover the existing infrastructure, the brownfield infrastructure. We can map that to existing services. We can do service provisioning. And the next comes the closed loop automation. So as a part of the closed loop automation, the first thing that happens is we will need to collect the interesting information that happens with configuring the telemetry. Telemetry is where we advise the ATOM platform to configure the various different sensors that the vendors may support for telemetry, and we can configure how frequently we want to receive the data, how long to retain the data in our database, and also from which devices we want to receive the telemetry information. And we support the Cisco, Juniper, and we're working on Arista as we speak, and we're going to be supporting more and more as we go. And as earlier question came up, we already support the more traditional version of telemetry like SNMP Trap or SNMP Syslogs. That's already supported. And this is the same way that we're extensible for services. You can deploy your own collection packages if required to collect whatever SNMP information is required. That's also some kind of information like telemetry for us. It's not streamed in real time, but it's still kind of that helps us to do closed loop automation. So that is the collection part for telemetry. And then once the telemetry information starts to stream into the system, there are a couple of options now. We can either go and build interesting reports, and the interesting reports could be, I want to see the top 5 interfaces in my network. I want to see the top interfaces with packet drops. There could be lots of different use cases that you can build. And if you see here, this is one such report where we're reporting the top interface utilization. And this report is utilizing the data from configuration. So the interface name is coming from configuration. The interface admin status and operational status is coming from SNMP. And the interface utilization is coming from the telemetry. So we have a mechanism through the intent-based description language we have where we can model this kind of a report as per the customer needs. This is a report that we have built for our customer, but customers can go and fine-tune this report or build a brand new report. So they have a massive amount of data available. All the data is described using the Yang model, and they can go in, index into the data and produce a report like this. And we'll take a look at how that gets done in just a moment. And apart from these interesting reports that we can build, the reports can be, as we can see, switching reports, routing reports, and as Chendu was pointing earlier, we don't even need to know what kind of reports the customers are going to build. And that's how flexible the platform is. And that's the infrastructure we'll take a look at in a moment. So other activity we can do. Now we have information. Information is flowing into the system. We built a report. Now we can also do closed loop automation. The closed loop automation is where we can write a condition on top of the data that's coming in. And the condition could be to watch like a particular metric, like interface status could be one metric, interface errors could be one metric. And the QoS provides a lot of these metrics also. And here, let's say, for example, if you want to monitor the interface flapping. So interface flapping use case is going to involve monitoring the interface status. And if at all interface flaps like 15 times, 20 times within 1 minute window, I want to raise an alarm. We can also have a scenario where I don't want to raise an alarm, but my standard operating procedure is so precise, the data I'm collecting is so precise, I actually want to act upon it. So if that is a scenario, we can actually go and auto-remediate the interface flapping by shutting down the interface. This is also possible. Or I can shut down the interface, but wait for a administrator approval. So this is the different workflow. So we have all of this interesting data flowing in. Now we can go and define these conditions. We can define the conditions on a window of data. The window can be 5 minutes, 15 minutes, 10 minutes. It's just up to the customer requirement. And a lot of use cases are possible here. So if you see, BGP neighbor flapping is one such use case, WAN traffic optimization, WAN utilization, QoS. And it can be use cases on the firewall also, like taking a look at the packet drops or firewall filters. Taking any remediation action also is possible. So this is on the closed loop automation. Any questions briefly?
So how difficult is it to write these?
So we're going to have quite a number of examples to use as a starter kit, but it's going to require some amount of DevOps kind of background. And the language itself is not that difficult. It's fairly. I think I will open up one of them. So if you look at the interface flap use case here, so it's going to involve selecting the appropriate sensor And the left-hand side is where we are writing the script to watch on a specific data. And the data is also a metric on the InfluxDB. And we're going to write some conditions that will allow us to go and do like interface up-down count. Like it flaps so many number of times, and then the window of time is like 5 minutes, 10 minutes. And on the right-hand side, this is our proprietary language to describe intent. So in this scenario, the intent is to raise a ticket for all the incoming alerts where the interface is flapping. And once approval comes in, we want to go and remediate it. It's going to require some amount of training, but the expectation from our side is we're going to build a number of them. Possibly over time, it may be hundreds of them. We're working with all the standard issues that we see. These are all coming right from the troubleshooting guides coming from the vendors. So we're going to build these as starter kits, but at the same time, customers should be able to write it. And we will help the customers write this, take care of this.
It looks like Apple script.
Tick script. This is a tick script from the Influx community. Yeah, the one on the right is Eden syntax like. Okay, and the same. So in this scenario, the IDSL is the language that we came up with to describe the intent to act upon the alerts that are happening. And the same language can also be used to generate the reports that we saw earlier. So these are the various different reports that we created. And if I go to the developer tools here, we'll see all the SDK capabilities here to browse the schema. And we can also go and write a sample DSL query. For example, I want to report the software compliance across my infrastructure. Of course, we have a report out of box. But let's say customer wants to write a report like this. So what we have on the left-hand side is a DSL editor where we're punching in some of this, and we can go execute this, and we're going to produce a report for a preview. And this is where the strength comes in. Now we can go and walk through any kind of data, write some conditions, and produce this report. And I can save this report, and instantaneously that report will be available as a part of the reports here. So in this case, the compliance report is the one that's going to be showing up in the compliance here. And it could be hardware compliance. It could be any reports on the load balancer. Let's say you want to write a report on the load balancer that monitors all the top VIPs, the number of connections open, or other metrics. You can easily write it. And this is one area where we are significantly different from other vendors out there. Is since we are cross-domain, it's not practical for us to be aware of all kinds of reports customers want to produce. It's not practical to kind of know all kinds of automation scenarios, all kinds of closed-loop automation scenarios. We provide a way to extend our infrastructure in all areas, device plugins, service apps, closed-loop automation apps, collection, pretty much anything that we can conceive of is extensible. And this is one such area. And also, the dashboard that we saw earlier, the dashboard itself was produced using this intent-driven DSL language. For example, if I open the dashboard itself was rendered using the IDSL. And it's just a matter of shaping the data and visualizing the data. So here, this card here pertains to this particular card here. And again, it's pretty much a breeze. Well, once you get a hang of it, we have enough starter kits. We can go and copy paste this, make some adjustments to go and index into the right kind of data. And we can massage the data we want. We can present the data to the not bound APIs the way we want. Any questions?
I have one. So you basically developed your own meta language to define actions, right? And my question would be like, why did you not think about developing a Python SDK with which people could program the actions without having to learn another language?
Yeah. Python SDK is supported too. So the alert we saw before, that alert will be published as a Yang notification using netconf. If at all you want to write a client adapter using Python, we can do that. We already support that for our service apps. In the service apps, the Yang model that we write for services has to be augmented in some scenarios with Java or Python. Same way, for closed-loop automation, we want to limit the amount of development that customers have to go through. So what we have done is we have come up with this meta language that's going to provide you a lot of macros. Because what we have observed is typically the kinds of things customers do when they're observing data is very repetitive. I want to watch this metric, and if it matches this condition, I want to take this action. I want to raise a ticket. So since some of those behavior is pretty commonplace, we have come up with this meta language. But wherever it is very complex, you can write your own custom function that is Python backed, or you can implement it in Python completely. But we will be able to support that kind of adapters. I think we're at the top of the hour. Any other questions?
I was going to ask, can you discuss about role-based access control for like the API and stuff like that?
Yeah, we have role-based access control pretty much across the product. You can define roles. We have some predefined roles, but you can easily augment them. And you can attach, including this menu itself is being shown to me because I'm at admin. And that also is controlled pretty much through role-based access control. What menu items I see, what capabilities I see is also controlled. Okay, to just summarize, to just reiterate some of the earlier points that came up, we are catering to a significantly scaled infrastructure, anywhere from hundreds of devices to tens of thousands to hundreds of thousands of devices, various kinds of data flowing into the system, configuration data, operational data, telemetry, and the data rate is different. The vendor interfaces are different. We have to normalize the data. There is so much happening with respect to what we're dealing with here. And that was the driver for us to build the microservices architecture that scales horizontally. It's pluggable, it's extensible, it's resilient, it supports DR. And that's what we have built. And quite a few of our customers are doing active pilots as we speak, and we're going to be in production with this infrastructure shortly. At the same time, we're also compatible with the industry. We are IETF Yang compatible. We support the IETF NACM, the Mono architecture. We are closely aligned with some of the happenings on the open config. And we are keeping pace in all areas practical.